What's going on, everyone? So we are now going to look at 4.4, and 4.4 is all about fractional exponents and radicals. Now, what can I do after this little video? Well, this video is going to go through how we can express powers with rational exponents as radicals and vice versa. So if we can see here, this is what we should be able to learn, that square root x can actually be represented using an exponent as a fraction. Okay, so it's actually x to the power of 1 over 2. So that means x to the power of 1 over 2, well, let's maybe put a number in there. So 4 to the power of 1 over 2, that's actually like square root 4, which is 2. Okay, you can further go a little bit more forward and expand on this, and if whatever your index is on your radical, okay, that actually becomes your denominator of your fractional exponent. Okay, so if we have 4 to the power of, let's make it 8 to the power of 1/3, well, that's like cube root 8. Okay, and then here, this will be in part 2 of this video. Okay, so it'll be a separate video for part 2. And part 2, this is kind of like the really intense thing. It's kind of neat, is that when you have a power, okay, and you have an index, your power is your numerator and your index is your denominator. Again, that will be more in part 2. Okay, so let's move forward and let's build on some prior knowledge. So something that you hopefully already know from grade 9 is that when you're multiplying similar bases, this means you add their exponents. Okay, so let's do a few quick examples going through that. So simplify the following expressions into one exponent. So a to the power of 2 times a to the power of 5. These both have a similar power of a. So what I'm going to do is take their exponents and I'm going to add them. So this will be actually a to the power of 2 plus 5. So this will become a to the power of 7. Okay, so this thing equals a to the power of 7. Okay, let's move on to b here. b, you can see that they both have a base of 2. So what we can actually do with their exponents is we can add these exponents. So this will be 2 to the power of negative 2 plus 3. See how I've made those both into one exponent? Negative 2 plus 3 gives me positive 1. So this is 2 to the power of 1. So this simply equals 2. So this equals 2. We can actually plug that into our calculator to just check that to make sure everything makes sense. So 2 to the power of negative 2, okay, that gives me 0.25. Then I'm going to go 0.25 times 2 to the power of 3. And what we're going to get is 2. Okay, and we were able to prove that using exponents, much easier. Let's move on to c here. So c, our similar base is x. So what I can do with these exponents is add them. So this will be x to the power of 3 minus 5. And what's going to happen there is I'm going to get 3, whoa, dang it, let's move down here. 3 to the power of 3 minus 5. And that's going to become x to the power of negative 2. Okay, and we are going to later learn how do we deal with this in 4.5. Okay, so this is 4.5. How do we deal with negative exponents? Okay. Now, let's get into what we're actually learning today. So what we're learning today is fractional exponents and rooting things. Okay, so you can represent any type of root by using fractional exponents. The index of your radical is the denominator of the exponent. So we can see here again, whatever your index is, it becomes the denominator of your exponent. So let's look down here and talk about these. So convert the radicals into exponents and exponents into radicals, if possible. So here we have a radical, number 5 is a radical. And remember, if there is nothing there, that means there's a 2. Okay, so this is square root 5. And our index is 2. So I can represent this as 5 to the power of 1 over 2. So there's my fractional exponent. Let's move on to the next one. Here I have cube root 11, and my index is 3, so that becomes 11 to the power of 1 over 3. So there's my fractional exponent. Here I have the fifth root of negative 3, So I can plug in -3 to the power of 1 over 5. So let's kind of see how our calculator works with these things. So we talked about how to plug in this into our calculator, right? We plug in 5, and then I'm going to press math, the option where it makes my number I just plugged in turn into the exponent. So I'm fifth rooting -3. So that gives me -1.24. Now I can actually plug in this. I'm going to do bracket -3 to the power of 1 over 5. Okay, and I'm going to bracket these actually, 1 divided by 5. And you're going to get the same solution because you're doing the exact same operation. You're just representing it here with a fractional exponent and here with a radical. Okay, so it's the same answers. Let's see here. The fourth root of 7. Now remember that our denominator is the index. So this will become our index. So this will become fourth root 7. So that's what the 7 to the power of 1 over 4 equals. Okay, let's move on. 25 to the power of 1 over 2. 25 to the power of 1 over 2, well, that becomes our index is 2 square root 25. And remember, if we have a 2 as our index, we don't even need to technically actually place it there. And we actually know what the square root of 25 is. It's 5. Okay, so this thing actually equals 5. And now we are doing the cube, or the -8 to the power of 1 over 3. So -8 to the power of 1 over 3, well, remember, my denominator becomes my index. So this will be the cube root of -8. And remember, this is an odd index. So what does that mean? That means my inside here can be a negative number. Okay, so what is the cube of -8? Well, I know that -2 times -2 times -2, well, let's talk about that. -2 times -2 gives me +4 times -2. 4 times -2 is -8. So this is -2 cubed. So here we will get -2. So because this is a perfect cube. Okay. So there is us breaking it down. Here is us showing it in a fractional exponent. Okay, well, actually as a radical. So that's how we can show and convert between radicals and fractional exponents, a super important part of mathematics. Let's move forward here. So remember in this I actually say 4.3, that's my fault. So remember what we learned in 4.3, okay? So that was the very last thing we just did. We learned the product rule. So remember, we were able to do this in our last video where we have the same index so we can multiply the inside numbers, okay? Now that we have different ways to analyze, we have new tools, so we can now analyze and understand certain mathematical situations in many different ways because what we also know is now our fractional exponents. And remember, if you are multiplying similar bases, you add their exponents. So we have 3 really useful rules here. So let's hear here. Simplify the following expression in 2 different ways. So here, what I'm going to utilize is I'm going to utilize this rule here, my product rule. So how can I analyze this? Well, this will be square root 3 times square root 3. The indexes are the same, so this will become square root 3 times 3, which is square root 3 squared. Remember, if your index and your power are the same, that simply cancels out. So this just equals 3. Let's analyze it in another way. Okay, I'm going to analyze it by putting this in terms of a fractional exponent, and then I'm going to actually add their exponents. So let's make these fractional exponents. So square root 3 times square root 3, well, that equals 3 to the power of 1 over 2 multiplied by 3 to the power of 1 over 2. Recognize we have similar bases. when you have similar bases, you can add their exponents. So this will be 3 to the power of 1 over 2 plus 1 over 2. And this will become, this already has similar denominators, so we can add the tops, 2 over 2, which is simply 3 to the power of 1. So this equals 3. So 2 different ways to find the same solution. Okay, now let's look over here. We can do the same for this guy. So my first method, method 1, again, I'm going to utilize the fact that they all have the same index, 3, 3, and 3. So I'm going to multiply their insides and put them all under one radical. So this will be the cube root of 4 times 4 times 4. 4 times 4 times 4, well, that's simply 4 cubed. And now you can see that we can cancel out our cubes. And what you're going to be left with is simply 4. So this just equals 4. Let's analyze it with a different method, okay? Similar to what we did below. What we did on the other one. We're going to represent all of our radicals in terms of fractional exponents. And then they're going to have similar bases, so we're going to add. So here, this will become 4 to the power of 1 over 3 times 4 to the power of 1 over 3 times 4 to the power of 1 over 3. Remember, we just make our index our denominator. And what's going to happen here is since we all have similar bases, 4, 4, and 4, just like up here, A and A, we're going to take our exponents and add. So what's going to happen is I'm going to get a single base, and I'm going to add all of these exponents. And then what I'll end up getting is 1 plus 1 plus 1, which is 3. So I'll get 3 over 3, 4 to the power of 3 over 3. And remember, 3 over 3 is simply 1. So 4 to the power of 1, which is just 4. So we get the exact same answers there. So now we have a bunch of different tools already to analyze different types of questions. Okay. Now let's learn one more rule, kind of refresh our memory on a grade 9 rule. Okay. So by this point, we should be really comfortable with our product rule. Now, a very similar rule is the division rule. Okay. It's where you have a similar index and you have a fraction in it inside. What you can actually do is you can separate those and divide them. So the nth root of a over b is the same thing as nth root a divided by nth root b. Okay, so let's simplify the following expressions in the exact value. So here, how can I analyze this? Well, this is square root 4 over 9. So what I'm going to do is I'm actually going to do square root 4 over square root 9. I know square root 4. That's simply 2. I also know the square root of 9. That's 3. So the square root of 4 over 9, well, that equals 2 over 3. So there's my solution. Okay, and again, we could plug this in our calculator and actually see it happen. So if I take the square root of 4 over 9, I get 0.66666, and this is going to go on forever. Remember, we learned that that 7 is just your calculator, not as smart as you. It's rounding. If I plug in 2 over 3, I get the exact same solution. So 2 over 3 is the same thing as root 4 over 9. Okay, let's move on to B. So for B, again, we have a fraction inside a radical. Well, let's separate this and make it the cube root of 1080 over the cube root of 27. Well, if you look here, 27 is a perfect cube, right? Because we know 3 cubed equals 27. So that means the cube root of 27 equals 3. So this equals 3 here. This one I don't quite know off the top of my head. So what I'm going to do is I'm going to take out my calculator and I'm going to see if it's a perfect cube. So I'm going to press math and then I'm going to cube root 1080. So it's not a perfect cube. Now, can I put this on top? No, because this is asking for an exact value. So what are we going to have to do here? Well, what we're going to have to do is utilize some of our other techniques that we've learned. We're going to have to break this down and put it into a mixed radical. Okay, so let's do that over here. So convert 1000, or the cube root of 1080 into mixed radicals. Okay, so remember, we know how to do this. We learned this in, I believe, our last section here. We learned it in 4.2. Yes, so we're going to use some, or sorry, 4.3. So we're going to use some 4.3 knowledge. So the first thing we need to do is break this down. So I'm going to divide this by, let's divide it by 40. Okay, and so, oops, let's clear that. For some reason it's not letting me press my clear button, so I'm going to open this back up. There we go. Okay, that was kind of glitchy. And let's get out of here. Okay, there we go. So 1080 dividing 40, that gives me 27. I can divide this by 2, and that gives me 20. Divide this by 4, that gives me 5. And divide this by 2, and that gives me 2. 27 dividing 3, that gives me 9. And then I can divide those by 3. Now remember, in order to put into a mixed fraction, we need to know what our index is. In this case, it's cubed. So I can represent the cube root of 1080 with its prime factorizations. So I can represent it as 2 times 2 times 2, and then 3 times 3 times 3, and then finally multiply by 5. And remember, my index tells me what I need to group these numbers into. So I need to group into groups of 3. So I have 3 2s there, I have 3 3s there, and I have 1 5 left over. So I can represent this as 2 cubed multiplied by 3 cubed multiplied by 5. And now I can separate them. So I'm going to use that product rule we learned. So this will be the cube of 2 cubed multiplied by the cube of 3 cubed multiplied by the cube of 5. So I've broken these up individually, multiplying them. And here I will get my cubes canceling out. So I'm going to simply be left with 2 times 3 times the cube root of 5. And that's going to equal 6 cube root 5. Okay, and let's maybe check and make sure that's correct. And how can we check? Well, we can say math, and we're going to cube root 1080. And this should be equal to 6 multiplying the cube of 5. And look at that. So we've checked that these two are in fact the same numbers. Okay, so what I can do here is I can come over here, and I have just figured out that cube root of 1080 is the same thing as 6 cube root of 5. So I'm going to represent this as 6 cube root of 5. And now remember, if you're not, this is being applied by a radical, so I can't divide 5 by 3, but what I can do is divide 6 by 3 because it's not inside anything. So 6 divided by 3, well, that's going to give me 2 cube root 5. And there is my absolute exact value. And it's also been simplified, which is really nice. Okay. So let's try C out and see what happens. Okay, so for C, we're going to do the same thing. I'm going to break it into 2 separate cube rooting. Now here, recognize I know that -2 cubed equals -8. Remember, you want to learn a few of these simple, the first few perfect cubes and perfect squares. So that means -2 equals the cube of -8. So this equals -2 on top. Okay, and I should put this as a single equal sign. So this will be -2 on top. And I'm actually pretty uncertain whether 189 is a perfect cube. So again, press math, which is right here, and I'm going to press the cube root, and I'm going to put 189. And it is not a perfect cube, so it gives me an irrational number. So I'm going to have to break this down as well. So let's kind of do that. So let's start off and start breaking down 189. So let's take 189, and I'm going to divide that by 3. So that works. So this will become 3 and 63. I'm going to divide 63 by 3. That's going to give me 21. And then I'm going to divide 21 by 3. And that gives me 7. So here, this is the cube root of 189. I can represent 189 by 3 times 3 times 3 times 7. Okay. And now remember, in order to make this into a mixed radical, I need to group in terms of what the index is. So my index is 3, so I have to group in terms of 3. So there's 3 3s, and I only have a single 7, so I'm going to leave that 7 alone. So this will be cube root of 3 cubed times 7. And now I can separate this even further, and this will be the cube of 3 cubed times cube of 7. And again, the whole reason we're doing this is because now we can cancel out our cubes. So this will become 3 times cube root of 7. So that's what this equals. So this will be 3 cube root of 7. And there is our final answer there. So let's maybe plug this in our calculator and just see if that's correct. So remember, I'm going to press math and then the cube root, and I'm going to plug this value in first. So negative 8 divided by 189. So that gives me a pretty ugly number, negative 0.348, blah, blah, blah. So this is an irrational number, of course, because you don't have a perfect cube here. Now I'm going to plug this into my calculator. So this will be negative 2 dividing, and I'm going to put brackets. Brackets because I'm dividing this whole term here. So I'm going to press 3, math, and then I'm going to go to my cube root. And now I'm going to press 7, and I'm going to get out of my square root, and I'm going to bracket that. Okay, so let's see what that becomes. And we can see that these are the same numbers. Okay, so we did it correctly. And we have now given the exact value. Remember, this is a really rounded value. This number is going to go on and on and on and on forever because it is irrational. Okay, so we've learned a lot so far, as you can hopefully see. And what we've also learned is your calculator is useless most of the times. It's good at checking solutions if you know how to use it, but at the end of the day, to find an exact value, your calculator kind of doesn't help suit quite a bit. So if a question asks you to give exact solutions, okay, if they ask you to give exact solutions, this means your calculator becomes almost useless. Okay, again, does it help a little bit? Yes, but your calculator would never be able to make this into this. Okay, you got to use your brain for that, which is pretty awesome. Unless something is a perfect root, it's an irrational number. Okay, just like we talked about here. If I plug this number into my calculator, you're going to get a bad number because it's not a perfect cube, making it irrational. Okay, to state irrational numbers as exact numbers, you must know how to simplify expressions. So that's in 4.3, and that's what we just did here. Becoming great at exponents takes a lot of practice. So trust me on this one, you don't want to just do the assigned homework, okay? Find practice problems. Find ones that kind of scare you and you want to try and get better at them, okay? And then let's state all of the current rules and tools that you should be comfortable with moving forward, okay? So right now, these are all the awesome tools you know and have learned before and should know how to use. So you have your add exponent rules, you have your product rule where you have the same index so you can multiply the inside values, okay? You have your quotient rule where it's under the same value here, and you can go in the backwards direction, right? If you have this, you can put it all under the same radical. We have our fractional exponents, and then you should learn how to go from mixed to entire. So here's a mixed to an entire, and here's an entire to a mixed, okay? So here's all the rules, and we literally just used pretty much all of these. We use them pretty much all right here, maybe with the exception of this one, okay? So let's use the following exponent laws to answer these two questions. So this will be the last thing to do in this video, and then part 2, we're gonna add one more new exponent law, okay? So let's evaluate the following powers not using a calculator. Okay, so challenge accepted here. So to not use a calculator, remember the first things you kind of want to do when you're not using a calculator is you may as well list the first few perfect squares and perfect cubes. So 1 squared equals 1, 2 squared equals 2, or 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36. So that should be enough for now. And again, we should represent this in terms of square rooting. So this is 2 equals square root 4, 3 equals square root 9, 4 equals square root 16, 5 equals square root 25, 6 equals square root 36. Okay, so there's my squares. Let's talk about cubes first as well, because you notice we have some cubes here. So here, let's list a few. So 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27, 4 cubed equals 64, and I actually don't know what 5 cubed is. I think it's 125, so let's check. 5 cubed equals 5 times 5 times 5. Okay. So 5 times 5 times 5. Our first 5's multiplying gives us 25 times 5. Okay, and then 25 times 5, well, that's 25, 50, 75, 100, 125. So I'm counting up by 50s. So remember, this is just 25 added together 5 times. So here's 25 times 1, 25 times 2, times 3, times 4, times 5. So it looks like it's 125. So here is 125. And again, you can represent this using cubes. So this is 1 equals cube 1, 2 equals cube 8, 3 equals cube 27, 4 equals cube 64, and 5 equals cubed 125. Okay, so let's move forward and look at example 5 here. So example 5 says 125 to the power of 1 over 3. Well, here, remember, we have our rule. We're going to use our fractional exponent rule. So my denominator is actually the index. So this becomes the cube of 125. And look at that. We were able to find this by listing the first 5 cubes. So the cube of 125 is 5. So that's pretty lucky on our end. So this will be 5 right here. Okay. Now, let's move on to our next one here. So this one's not as simple. I'm not going to list all of the powers of 4, plus this is a huge number. But what I can do is I can list this as 4th root 4096. Now, let's evaluate this using our prime factorization. So here, let's divide this by 2, and that's not super hard to divide by 2. 4096. What same numbers add to this? Okay, so we're not supposed to use our calculator, so we could do this here. So how many times does 2 go into 4? Well, it goes in twice. Okay, and then we subtract that. That becomes 0 and 0. Okay, so this becomes 0 here and 9. So how many times does 2 go into 9? 2 goes into 9. Well, that goes into 9 4 times. 2 times 4 is 8, and then subtract, and that gives me 1. Drop our 6, so that's 16. How many times does 2 go into 16? That goes into it 8 times. So this will be 16, and that's 0. Okay, so far, if I divide this thing by 2, I get 2,048. And you probably could have figured that out without doing long division. If you don't remember long division, please come see me. Okay, it's not absolute that you need to know this. Remember, you probably won't get this hard of a number to divide by. Okay, let's divide this thing by 2. This one's a little easier. This becomes 1,024. Let's divide this by 2. And this becomes 512. Okay, and all I'm doing right here is 24 divided by 2 is 12. 10 divided by 5 is 12. Okay, 512. So divide that by 2. And this is going to become 256. Okay, and then we're going to divide that by 2. And that'll give us 128. And then we're going to divide that guy by 2. And that'll give us 64. And then 64 is divisible by 2, 32. And this gives me, divide by 2, which gives me 16. Divide by 4s, which gives me 4. And then finally 2, 2, 2, and 2. So that was a pretty ugly number to have to deal with. You wouldn't have to deal with something like that on your test or anything like that, just so you were aware. Now recognize it wants us to group into 4s. So here I have my first group of 2s. And then I have another group of 2s that equals 4. And then I have a remaining one down here. So there's another group of 4s. So what we can do here is we can represent 4,096 by 2 to the power 4 times 2 to the power 4 times 2 to the power 4. So this will be 2 to the power 4 multiplying 2 to the power 4 multiplying 2 to the power 4. And from there, this thing looks like it's a perfect fourth root, because this we can represent as 2 to the power 4, 2 to the power 4 times root 4, 2 to the power 4. And again, these all cancel out nicely. So we get 2 times 2 times 2. 2 times 2 times 2 is 8. So it looks like this thing actually just equals 8. Okay, again, you probably wouldn't see anything like this on your assignment or your exam. And if you did, you would definitely be able to use your calculator. Okay. Here's more of a question that you would be expected to be able to do without a calculator. Okay. So here, I'm going to use my rules here. So I'm going to apply, first of all, my fractional exponent into a radical. So this will be cube of 27 over 8. And then I'm going to put this into 2 separate radicals. So this will be cube of 27 over cube of 8. Cube root, sorry. Cube root of 27 and cube root of 8. And these are things that we know. We look over here. 3 cubed is 27. Okay, so that means 3 equals the cube root of 27. So this equals 3 over, and we know the cube root of 8, which is right over here. So the cube root of 8 is 2. So this thing equals 2. So this guy will equal 3 over 2. And we know that also as 1.5. Okay, so I would stop here. I would go practice a few questions before moving on to part 2. Part 2 is a little bit more difficult, and please come ask any questions that you may have. Other than that, have a good day.